All right, in these notes, we're going to look at slope-intercept form of linear equations. So you may remember slope-intercept form, y equals mx plus b, where m is the slope of a line, and b is the y-intercept. And with those two numbers, you can graph pretty much any linear line, any straight line, as long as you have the slope and the y-intercept. So first of all, we need to get that information from the equation, and then we can graph the line. So on example A here, we can see that m, our slope, is 5 over 2, and b, our y-intercept, is 1. So when you graph a line using slope-intercept form, you want to start with the y-intercept because that's where the line crosses the y-axis. So it's an easy place to start. Our b value here is 1, so we start at 1 on the y-axis. The slope is 5 over 2, and if you remember, slope is rise over run, which means it's our vertical distance over the horizontal distance. And so we're going to go up 5 spaces and right, because it's positive, 2 spaces. So from 1 on the y-axis, up 5, 1, 2, 3, 4, 5, over 2, make a new point. Technically, that's all we need for a line, but it's usually a good habit to do that a few more times. We can also go backwards and go down and left, just like that. And now we can just connect the dots for the line. Let's look at the next example. Y equals 2/3 x plus 2. M is our slope, b is our y-intercept. So we start at 2 on the y-axis, and the slope is 2/3, so that's up 2, right 3, because it is positive, so up and right. Up 2, right 3. And I like to do this as many times as I can before I run out of space. That way, the more dots you draw, the easier it is to draw your line. Let's look at example C. Now example C here isn't in slope-intercept form exactly, right? Because we need it to look like y equals mx plus b. So we have to actually subtract this 3x to move it to the other side of the equation. So y equals negative 3x plus 1. So there's a good equation in slope-intercept form. Whoops, 1 is our intercept, not our slope, and negative 3 is the slope. So we start at 1 on the y-axis. Since it's negative 3, that's negative 3 over 1. And the negative tells us we're going to go down and right. Negative slope goes down to the right or up to the left. Just like that. Okay, last graph here. We also have to solve this one for y. Move it to slope-intercept form by subtracting 2x. So y equals negative 2x. So here we don't have a b value. Our slope, our m, is negative 2. There's nothing here. So you can imagine a plus 0, and that 0 is our b value. So that's going to be right here in the middle. Then we go down 2 over 1 because it's negative. So we're going down to the right. And again, it's over 1 because anytime you have a whole number, it always has a fraction bar with a denominator of 1 that we don't have to write. So any whole number is going to be over 1. If it was positive, we'd go up and right. Negative, we go down and right. Okay, so there's our sort of 4 graphing examples using slope-intercept form. Now let's use slope-intercept form to represent a linear function. So example E says, Mr. Preston wants to rent a movie. It costs $5 to start an account. It's a one-time cost. And $3 per movie. Write an equation that models this. The key here is understanding that this $3 is happening per movie. And the $5 is a one-time fee. So anytime you have a per movie, or per hour or per something. That's going to be your slope. So we want 3x here. And then plus the $5 fee. So there's our equation, y equals 3x plus 5. How much does it cost to rent 3 movies? Well, if it's $3 per movie, 3 is going to be what we put in for x. So that's going to be 3 times 3 plus 5. Well, that's just 9 plus 5, which is $14. How many movies can Mr. Preston rent with $65? Well, I'll just plug that in for the other variable, the y, that's our total. So 65 equals 3x plus 5. So now we should solve this. So subtract 5, 60 equals 3x. Divide by 3 and x equals 20 movies. Okay, lastly here, without an account, movies cost $5 to rent, but there's no account fee. How many movies does Mr. Preston need to rent to justify the cost of starting an account? So what we need to do is compare the costs with and without the rental fee or the account fee. So with an account, we know it's y equals 3x plus 5. And without the account, it's just 5x. So we can sort of compare and think about how much it'll cost for 1 movie, 2 movies, 3 movies, that kind of thing. So we know that 1 movie, when x equals 1, this would be 1 times 3 is 3 plus 5 is $8. And this would just be $5. So with 1 movie, it's cheaper to not start an account. Let's see about 2 movies. That's 6 plus 5, that's $11. And this is still 10, so it's still cheaper for 2 movies. Let's try 3 movies. 3 movies would be $14, we know that from above. And this would be $15. So already at 3 movies, it is cheaper to pay for the account. So 3 movies to justify the cost of starting the rental account. So just comparing those 2 equations there. Okay, let's look at example F. Mr. Hoke is weighing glue sticks for a project. The bin he is using weighs 10 ounces. And each glue stick weighs 4 ounces. There should be no T in that word. Okay, so the key here, 4 ounces per glue stick. Each glue stick is 4 ounces. Write an equation to model the total weight. So that would be y equals 4 ounces per glue stick plus the 10-ounce bin. What is the total weight with 5 glue sticks in the bin? Well, we just put in 5 for x. So 4 times 5 is 20 plus 10. That would be 30 ounces. If the total weight is 130 ounces, how many glue sticks are in the bin? So 130 equals, just use the rest of our equation, 4x plus 10. And now we have to solve it. So subtract 10 for the weight of the bin, that's 120, equals 4x. Divide by 4, and we have 30 glue sticks. All right, so there are the linear model questions where we're using slope-intercept form to represent a real-life situation. And don't forget, when you graph, start at the y-intercept, use the slope to find the next point.